right. I think I've got everything up and running on my end. If folks can let me know if they can see and hear me okay, then we'll get this crazy party started with more questions than answers, but we'll hopefully learn and figure this out together. So if folks can let me know if they can see and hear me okay, that'd be great. And we'll be relying on the live chat probably a little bit more than we normally do. 5x5. Oh, good. So folks can see and hear me. Thanks, folks. We're just going to get started. No shout outs today, no pregame activities. I'm Geology Professor Shawn Willsey. It is April 7th, Sunday. It is about 1:16 p.m. here, Mountain Daylight Time. That would make it about 7:16 in the evening in Iceland. And as you can see from our webcam view here, we have some different eruptive behavior that necessitated this live stream. So appreciate Amanda Joe for alerting me to this along with some viewers. Like many of you, I was kind of having a lazy Sunday. We played some pickleball with some friends this morning. Was thinking about maybe taking a nap. But we're here instead. The reality of this live stream is it probably won't be as long as others. I do need to drive down to Salt Lake City to have dinner with my daughter tonight and then have a presentation tomorrow in Salt Lake City for the Utah Geologic Association. But I think we've got time for a good solid hour or so to dissect what's going on here. I'm learning all of this on the fly, so this is very much a blind live stream. So I'm going to rely on your help and comments, and if you have data or sources, if you can share those with the moderators. Thanks to Susan and Amanda Joe for putting all this together for us. Is everything looking good? Okay, I thought I saw someone say no video, but yeah. Okay, so we're good. Yeah, so briefly to summarize what I know, and anything I can say in the next hour may be wrong and erroneous. So I will apologize ahead of time. I have not had a chance to look at much sources. I don't think there's a lot out there. I do know an Icelandic gentleman, Isaac, who many of you know, was trying to get a drone up that would have gave us some good information and data on where this flow is going, but apparently it's quite windy, and I don't think he was able to get to the position he wanted to. So instead of his live stream with some awesome footage, you are stuck with me. But what we have here is we have our spatter cone, the northernmost cone or vent that had been erupting fairly, I would say consistently and with some regularity over the past few days. And it had lava circulating and spatter shooting out of the central crater here. But there was also a vent of lava at the base that was feeding this channel and lava flow here. And now you can see the behavior has changed quite a bit. The lava lake in the vent in this crater has risen considerably, and now we have lava spilling over the rim of the spatter cone, and that's actually feeding these channels. It looks like some of the lava is spilling off here to the, I guess that would be the west. A little hard to tell exactly where all of this is going here, but it's feeding presumably this channel here to the southwest. So I'm going to be pausing a little bit here and there because I do want to follow you guys in the chat as much as I can, because you may know much more about what's going on than I do. So this is definitely a team effort, and I'm going to rely on my good teammates out there to help me share good information and help us all learn together. Apparently this began a few hours ago. I'm sure someone has the exact time. I do have a couple of things loaded up here, and Amanda Joe also sent me a little video showing when this began. But apparently the cause of this was the lava that was flowing out of the base through the channel. That conduit became blocked at some point. And so that backed up all the lava behind it, raised the level of lava in the spatter cone to the point you can see here where it's just spilling over the top and feeding these channels here. Now, what we might expect moving forward is this moving lava coming through this very impressive pathway in front of you here. And you can see it's a little surgy, right? There's places where it stalls, like right there. Then there's a surge that spills over the top. So here comes a surge right here. It's almost like little waves, like little mini tsunami waves, if you want to think of it that way. So the splashing and the convection of the lava caused by the gases coming out at the surface here and splashing all the lava around. As these big lava bubbles burst near the surface, that's what's feeding these big surges of lava over the rim and coming down the front. But what we might expect moving forward is this channel might start to get cut deeper, because we have the lava spilling over this rim here, and this excessive heat, we might expect some thermal erosion along that part of the spatter cone's rim. And so this could create a deeper notch moving forward. That's something I would expect to possibly look for if this pattern of behavior continues. That'll, of course, allow more of the lava to empty out, and it could lower the lava lake level behind the rim here. So those are just a couple things in looking forward. It's pretty spectacular. I mean, this view is incredible. So great job with the webcams, just looking straight at the guts of this thing here moving forward. So let's stay with this for a minute, and then I do have a couple things to show you. Not a lot. We might just end up sort of talking about this here. But of course, the main concern I would have at this point is with this lava spilling outwards a little bit faster as it comes down the rim of the spatter cone, is of course, where's this going? Now, it looks pretty impressive coming off this front face of the spatter cone, because it's running down a 35 degree slope. But then it's hitting the base here where the topography is quite flat. And so is this ponding up and accumulating in the typical areas we've seen over the last several days? What does the flow field look like? So right now, the biggest burning question in my mind is not so much what's happening here at the vent. It's where is all this lava going? Are there tube systems being fed? Do we have any active tube systems where the lava is flowing beneath the solidified crust and moving down slope in some direction? And of course, the lava flows over the last 2 weeks or 3 weeks, I suppose, has drastically changed the topography and the lay of the land here. And that is, of course, influencing the exact direction that this lava may head moving forward. But right now, that's about as sexy and juicy and awesome as it gets, friends. That's just really an attractive eruption to be able to watch that there and watch these surges, these lava gas bubbles bursting near the surface and then feeding these surges of lava spilling over the rim. Pretty spectacular. Okay, so we're doing this all on the fly. And I will trust that Amanda Jo, because she's got a direct she's got the bat line, the telephone line that goes directly to me. So if there's anything I'm missing in the chat, Amanda Jo, or something that you've sent me by way of a email or anything, just let me know. It's just something to get my attention there. So, because as some of you know, I can get kind of sucked into looking at my screen and yapping away, and I might miss something good that you good folks have to say. So, yeah, pretty cool stuff. So I appreciate everyone for joining us here today on this Sunday afternoon or Sunday evening, wherever you are. Maybe it's Monday. Thank you, as always, for our moderators. And I think we will probably have time to handle a few questions. I know there's probably a lot of questions, but I'm going to keep this to a little bit over an hour probably, just so I can get in the car in time and go have dinner with my daughter who's down in college in Salt Lake City. So this is awesome. This is important, but that's a little bit higher on my list, at least for today. So let's see. So let's pull away from this webcam. I know it's enticing. It's just, this is again what I call lava therapy. You can just watch this, and the only thing that would make this slightly better is if they had this mic'd up, if you could get a microphone close to it and have the sound effects added with it. If the webcam had a mic on it, all you'd hear on a day like today in Iceland is the wind. But let me pull you away from this just for a few minutes, if you don't mind. And this news story here appears to have caught this when it began. I don't know exactly what time this occurred, but you can see the lava lake level in the interior had risen, and then you're starting to see some of that spillover there over the spatter cone. So you can see the flow at the base had been pretty much arrested at this point, so that conduit had been clogged. Very windy, so the camera bounces around a little bit here. But as that conduit at the base of the volcano that was feeding the lava channel was plugged up or clogged, that allowed the lava lake level to rise in the crater. That eventually caused the spillover here. The spillover occurred at this side because this is the lowest side. That back side of the spatter cone is higher. It has a higher walls on the east side there, and the southwest side is the point, the weakest point in terms of where that lava might spill over. So this nicely shows, and this is, I'm watching this for the first time with you, friends. This is when this began. Lots of movement there with the camera. We could maybe speed this up a skosh. It's about a 4-minute clip. Can we speed it up a skosh? What do I need to do here? Here we go. Let's go 1.5 times here and just speed it up a little bit. So if you're getting motion sick, look away. Windy day in Iceland. So you can see as the lava started spilling over, eventually that started thermally eroding a little bit and causing it to cut downward a bit. So this is kind of neat here to be able to see the initiation of this behavior, that each surge of gas in the vent caused the lava to spill over the rim, preferentially on this low side here. And it's a balancing act because as the lava spills over the rim, it does coat it and build it up. But eventually, I think you get a little bit of thermal erosion along this level as well, especially once you get more of a continuous supply of lava spilling over like we see in the live cam. So this looks like this was 3:30 local time, around 3:23 local time in Iceland. That would make it 9:23 here, and it's, yeah, so about 4 hours ago. This is when this all began. It's almost at the end here, but great that they were able to capture sort of the beginning of this. So we'll watch this. So the surges just get bigger, right? As the lava lake level in the crater continues to rise, backed up, and then you end up all this material has to go somewhere. Instead of coming out that lower channel, it's all surging out the base. And as this lava spills over the rim, that presumably might be clogging or plugging up the outlet for that lava channel. Remember, we had that lava channel being fed at the base, and that was feeding the lava flow that was coming out this bottom part. But as you start draping more lava off over the wall and onto the flank there, well, it looks like that was the end of that. So okay, and then what I have here, this is a different view. Again, I haven't seen this at all. So this is a live from Iceland webcam, and I just took it back a few hours. It looks like it's about to 3:02. So let me see if I can bring it a little closer. So this is even earlier. You can see it's not spilling over the rim there, but you can also see there's not, from what we can tell from this view, and the lava flow from the base is not happening. I wonder if we can see that going back further. A little harder to tell. Yeah, it's just the lighting's not awesome there, so a little hard to tell. And now I've really done it. Let's go back to where we were. Not that far. So here we are. What time is this at here? 2:40, so that's a little bit beforehand. This is 3:28, so there it is. Yeah, let me go back just a skosh. I mean, it's the same thing we saw, essentially, just different view. But then we can maybe either skip forward or set this a little bit faster. Again, I'm just watching this for the first time with you. This is sped up at 2 times speed, so realize you might see it, looks like the volcano's a little extra angry there, but that's just a little bit faster than regular speed there. But you can see those surges coming over the rim. And Amanda Joe, thanks for sending me all this stuff. You guys are awesome. Yeah, I don't know if I'd been able to pull all this off on my own. So big shout out to Susan and Amanda Joe for being ready to just dive in. They were ready before I was. And also to the viewers who let me know that this was happening. Yeah, so we can, yeah, and then at some point they zoomed the webcam in a little bit closer. So, and let's see if we can figure out here a little science on the fly. What I'm going to do is this is several hours. This is about 3.5 hours old, the view you're looking at there. But I'm going to skip it forward, and you can see where the lava is spilling over the rim here. What'll be interesting to see is as we move forward in time, is does that level drop? In other words, is the thermal erosion that I speculated was going on along this rim, is that actually happening, and is it cutting a deeper notch there? So let's kind of keep that in mind and then skip forward. Hard to tell, inconclusive. Just eyeball test, maybe a little bit. Looks like it gets narrower. And that makes sense as well, because as lava is sticking along the margin, it might get narrower as well. So let's see. I think it maybe dropped a little bit. It's really hard to tell. It's subtle. But definitely we can see that it narrows a little bit, right? Look how wide the channel, the outflow channel is here. And then when we zoom or bust ahead to a few hours after this view, you can see how much narrower the conduit is. And narrowing it, as you guys can probably figure out on your own, that should increase potentially the speed of the lava through that little channel, which could cause a little bit more erosion, thermal erosion along the bottom. So, so I put that little piece together for what it's worth. You can see some of the lava has started to spill out here and head down what I believe is presumably sort of the west side, but a minimal amount of flow. Most of the flows heading down into this main channel. And I don't know if there's a tube system or some subcrustal level flow going on. I wouldn't be surprised if we're feeding with lava that fluid and hot, if we're feeding some tube systems just below the crust as well. So, okay, so there's that, and then let's go back to see the view for now. So here's our live view, and again we can see some of that flow heading off to the west. You know, maybe 10% or so of the lava output is being channelized off the spatter cone, heading off into this direction. The bulk of it is moving into this area. Can't tell where this middle part of the channel goes. Does that is it going under this block here and then popping up somewhere else? Not sure. And then let me go quickly to this is what Amanda Joe sent me. Excuse me. She had put together a clip. This probably shows the same thing that we've been watching. So, but I wanted to hope to see. And actually, this is a pretty cool view here. I wonder, is that the out? That is the outlet, isn't it? Right there. So that's the outlet that gets plugged up, because you can see the lava channel coming across the base here. So let's see if we see over time, and this is just a 2.5 minute clip, so we can hang in here. You can see the lava lake level's risen, but it hasn't quite overflowed yet. Here's the first little surge down the outside. I think this outlet channel at the base, it's not completely clogged, but it's mostly clogged. Like, you just don't see lava moving through there. You just see a little bit of glow. And here's that initial surge over the rim at this low part of the spatter cone. And then this kind of just gets going from here. I mean, this is our third time watching it, and I'm still learning. I'm still intrigued to see what happens here. So it's this balancing act, right? Like the lava giveth and the lava taketh away. So when it explodes like that and it adds stuff to the outer slope, that stuff mainly stays there. But when you get the lava flowing, especially flowing with speed and that kind of energy level from a high elevation to a low elevation, that's when it can start to be more erosive and actually erode the very spatter cone it constructed. So we may be seeing, even though the volcano's been building up this nice, sexy cone over the last 2-3 weeks or so, we may see some part of it get eroded. The other thing we might look for is a big section of the cone could have to actually get rafted off with the flow. So as this thing thermally erodes, it can undercut, and if it creates a deeper notch or channel here, it can undercut these flanks on either side, and you may get the lava flow coming out of the vent actually carrying a big chunk of the cone out with it. And that's what we call a rafted block. That will just get carried out by the flow and then dropped on the landscape somewhere. There's excellent examples of that in places here in southern Idaho, like at Craters of the Moon, where we can see big chunks of spatter cone, or in some cases cinder cone, that were carried away from the vent area by the lava flow itself. I mean, this is great. This is, I mean, even if you had a drone here, like, I don't know if the view gets any better than this, right? Like, this is pretty top shelf stuff here, team. Um, let's see. So I got a couple things from Amanda Joe here. We'll let that run. Looks like that's pretty much it for that. So thanks for sending that, Amanda Joe. Let me circle back to some of the other things you sent me. So it is getting a little darker in Iceland, so we're getting a nice contrast there. And she has sent me some other things here. There's a great view now at this site, so let's pop up that view here and see how different that is. Oh, let's watch our 5-second ad first and pay the man. Okay, isn't that the same view I was in? Yeah, that's the same one I was in. Okay, good. Then she sent me one that's a close-up, so let's try that one. That's on live from Iceland. So similar view there, I'd say, and that's actually the one I had up too. So I think we've got both of these views here that are pretty nice. That one's kind of straight on. This one a little bit more oblique view. So this one's a little bit further to the west. This one looks like to me is a little more to the south, perhaps. Yeah, no earthquakes, and so we can look at that. I haven't looked at the GPS data yet. I don't know if it's particularly telling at this point either, because this just began today. Let's come back to, let's see, anything else I'm missing over here, team? Let me scroll through the live chat. If you look very carefully on the bottom right of the cone, you can see a tiny stream of lava coming out of a hole. Yeah, I can see that right there. Remember, these cones are porous and permeable. So as the lava in the vent area thermally erodes some of the spatter cone itself, it can start to, if it can find a pathway out, it might. And so remember, this was actually much lower, right? So the way we'd seen this thing erupting in the days prior was it was still spattering and shooting up little clots and blobs of lava, but from a small confined lava lake that was several meters, maybe a few tens of meters lower than the elevation you see here, because we had much more of that lava coming out the base of the cone, directly up from the vent, from depth to the base of this spatter cone and then out. And now that vent out the base of the cone has presumably been choked or constricted or cut off, and that has raised the lava level in the cone so that now we're seeing more spillover, which is pretty impressive. So again, a little bit of the flow here along the left side, which I believe is to the west, because we're looking probably northeast-ish here. And then it's feeding a lot of this lava channel here. But what we're really waiting for, and what I'm hoping someone can find out there, if you do see it, is the flow field. Like if there's, if we can get a helicopter overflight. Obviously the drones aren't helpful with the wind speed being what it is, but it would be interesting to see where this is going. Is it all on the surface? Is some in the subsurface moving through tubes? Remember, lava tube systems are an effective and efficient way to transport lava big distances downstream. Like in Hawaii, you can get flows moving 30, 40, 50 miles, so like 70 kilometers away from the vent through a lava tube system. In a typical lava tube system, for every kilometer the lava travels, it only loses a degree or 2 Celsius of temperature. So it's incredibly efficient in terms of keeping that lava hot and molten and transporting it big distances. Obviously, when the lava is at the surface, the temperatures are much cooler. It can crust over and slow down much more rapidly. But I would not be surprised if we have some lava tube flow through this flow field here. So we'll have to see how that works out moving forward. Okay, I guess there's questions already being sent to me. I will try to tackle those as best I can. Realize I'm just, all I have right now, team, is this view and a Met Office update. And I realize they're busy, so by no means am I judging, but there's nothing here so far. Everything is from April 4th, so nothing to speak of there. The earthquake data is nada, and the GPS data, I haven't looked at this yet today, but Let's look at the 8-hour run here. Yeah, I mean, it looks like there was a little bit of an uptick. On my last update, we talked about this upward trend in the elevation, and the last couple points here show it more stagnating, so a little bit lower there. But I think the big question right now is not so much looking at some of that data as it is observational data. Right now, what we need is eyes in the air or nearby to show us where some of this lava is actually headed. That's at least what's of most interest to me. Okay, so let me go to the question sheet and I will try to, yeah, Amanda Joe says no flyover videos from the Coast Guard yet. So they may get something up this evening. I think the wind is a little too much for the drones to handle, but I don't, based on what I know, I think the helicopters would be fine. So I am going to try my best to take a stab at some of these questions. And I'll just leave the live webcam view up. I think that's much more appealing than looking at the question sheet, if that's okay. So a couple questions, and thanks again to all the viewers. Real quick, let me just do a quick reset if you're just joining us. A few hours ago, maybe 3 or so hours ago, the basal conduit of lava out of this northernmost spatter cone, at this point the only erupting vent. Oh, there goes a drone right there. Someone's got a drone looking at it. That vent out of the base of the cone was somehow plugged or choked or constricted. That caused that so that the lava could no longer flow out of the base of the cone. That caused the lava lake level in the crater to rise and ultimately start spilling over the rim. And that's what we have now is all that lava that's being fed to this vent is at a higher level, and the only pathway out of the cone is this spillover here. What we may see if this sustains itself is all these bursts of lava here at the rim will actually add more height to these other walls of the spatter cone. Remember that when we had this thing, 12 hours ago before it started behaving this way, the cone was, 20-ish meters high, but as the lava supply, if it were to wane and we can't get lava up to the rim, then that's sort of, that's a limit on how high your cone can become. But now that we've got lava freely and much more lava freely spilling over the rim, spattering onto the rim, presumably that might make this cone much steeper moving forward. But we've had this spillover for a few hours. We're hoping to get some information and data that might show if the flow field has changed behavior. It might not, because all we've really done here is changed the vent from the bottom of the spatter cone. Now it's coming out the top, and because it's spilling over the steep side of the cone, it looks very attractive and it's moving very fast, which makes you think it's a little bit more dramatic. And I think visually right here, this does look dramatic, but I don't necessarily expect there to be a huge behavioral change in the flow field in terms of its size, area, or extent. But I'd just be nice to have that verified by some overflow data. So, okay, back to the question. So the first question is, why doesn't the ridge it is cascading over actually give way? Well, if you think about this wall of this spatter cone, you've got this tapered side down here on the flank, and this is all at the angle of repose, so that's maybe like a 35-degree angle here. And then the interior wall is probably much more vertical. It's much steeper, but essentially it's forming a wedge, right? The point is you have a lot of mass. So even though the lava is pushing on the wall, the actual geometry of this thing, kind of like a right triangle, if you will, is buttressing the flow of lava. And the lava has a clear, easy pathway out of the crater down through this channel. And that's keeping this thing from breaking up. Now, that's not to say that it couldn't break up, right? So if we saw, a big fracture form on one of these walls here on the flank of the spatter cone, that may cause one side of the spatter cone or a wall of it to give way. So the ridge, that would be my take on why the ridge is actually able to sort of buttress and maintain the flow of lava. You have to remember that the lava itself, even though it's moving, its density is the same as the black rock making up the cone. And the cone is actually solidified for the most part. It's not moving. And so it has quite a bit of force to to withstand this surging, flowing molten lava? So good question. Um, and then they have, let's see, local time 2:57. Everything starts. Side flow, emptied lava lake, output vent clogged, lava level rises in cone, then overflows. So they just had a time stamp there when that started. Excuse me. From Hadley, have the other fissures shown signs of becoming reactive? Not that I know of, and I wouldn't expect there to be any change in any other fissure. So I'm not at this point concerned with one of the other two cones or vents that were active previously in this eruption, a few days or a week ago, becoming reactivated. That would necessitate a stronger supply of lava into the system. But this cone is handling it quite well. We didn't, again, even though it looks like there's more lava erupting from this, that may not be the case. I think it's actually just coming out of the top rather than the bottom. And as it spills over, it's just a little bit more dramatic. And so it visually, it looks like there's a lot more happening there. From Gabriel, did the lava effusion rate increase? I don't have data, so I can't say for sure. I don't know. That's the best answer. But my guess is possibly not. I think you can switch to this type of behavior just with the sequence of events we've talked about here by plugging up the basal outflow channel and bringing the lava lake level up and then having the lava spill over the rim. So there's no data, at least that I have so far, that suggests that the supply of lava being erupted at the vent has increased at all. But great question, and we'll just have to see going forward if there's any data to support that. So how are we doing here, team? This is good stuff. Yeah, for those that are helping support the channel and donating, many thanks. Mr. Money BTC, I know the moderators usually do a thank you whenever that happens. If I see it, though, I do try to give you a quick shout out and appreciate you supporting us here on this Sunday afternoon. The moderators and we could be doing something else, but we feel like this is important, and we feel like we want to share this, right? We want to be here with you, witnessing these changes in the eruptive activity and lending what we can to your experience. From Tanya Davidson, so amazing to see, scary, but amazing. Shawn, have you ever witnessed an eruption like this? Not an overspilling fissure or spatter cone. In 2022, when I was in Iceland, there was a spatter cone, but there was a notch in it, and it was feeding lava out of that. It didn't spill over the top. And I was some distance away. It was probably a couple hundred meters away, but not as dramatically as spilling over a steep side like that. But nonetheless, I'd say this type of behavior here is similar to what we saw with the three quote-unquote tourist-friendly eruptions at Fagradalsfjall volcano just to the east, the 2021, the 2022 eruption, which I was able to witness, and then again here in 2023. While we're on that question, though, let me see if I can, I don't know if I can do this on the fly or not. Perhaps not. I can pull up, because I do have a couple pictures from that eruption, and we might be able to see if that type of eruptive behavior was similar. All right, here you go. This might help a little bit. So here's a picture of me in 2022. So you can see the cones back there quite a ways. Here is a little better picture, perhaps. So here's the lava flow in the foreground. Yeah, it's kind of hard to tell. The cone was not nearly as big as this one that we're talking about right now. And then I guess I've got a couple more. Let's see if these are helpful at all either. Yeah, a little hard to tell there. But you can see the main thing here that I remember was it was erupting here. There's the vent, but then there was this channel coming out here to the north that was feeding this flow. It was swinging around the corner, and that's this lobe you see right here in the foreground. And then let's see, one more picture. I don't know if, yeah, the similar view there. But I remember like looking at this lava channel over here, and even from this distance of a few hundred meters, you could see it was moving quite quickly. But it didn't really form. This eruption only lasted 2 weeks or so, maybe 3 at the most. It didn't really build up a nice proper cone like we're seeing here. And I think I have only one more picture of the eruption. This was a couple days later. I went back and it was raining. I guess there was a little bit of a cone by that point, so I stand corrected. And then you can see the outflow there, right? So you can see, we don't want to look at myself. So you can see there was a cone and a channel there, but this cone was, I'd say, is half the height of the one we're seeing erupting today. And so there wasn't an elevated lava lake. It wasn't spilling over from as high of an elevation. You can see the level of the lava in the crater, maybe something like this, and then it sort of cascades down this notch and then fans out in this big valley down here. So the other fun thing you can see in this photo, just as a fun side note, is see that scar between my eyes. So this is the last day I was there visiting the eruption. On the first day, if you look at one of these other photos, like notice I'm okay, right? Like you don't see that big scar there. And that's because on this day, I went down to the active flow front and stuck my rock hammer in and took a sample. And I had sunglasses on and I had a thing over my nose, like a scarf. This is the day I met Dr. Ariana Soldati from North Carolina State. And I was pretty well protected, except this little strip between my where my eyeglass lenses are was not as well protected. And so I did get a little bit of a burn there that I didn't even know about until later that evening. So that's what I call my lava kiss. It's of course healed and no longer scarred, but there's a little fun story along with that there. So good stuff. Let's get rid of all these pictures and go back to this. So did I answer the question? Yeah. So have I witnessed an eruption like this? I guess I did, but not exactly like this. This is a little bit more dramatic, and at least the webcam here with the zoom lens makes it look much closer than anything I've experienced. So fun stuff. From Martha Jamsa, I wonder where that lava with increased speed will pool. Well, it's really only, its increased speed is coming down the flank. Notice that the flow out here in the foreground it's moving, but it's definitely slower, right? So even though it's moving quickly down this slope because it has an elevation drop, a steep elevation drop at that, it's quickly, it's probably creating a bit of a pit right here. There's probably some thermal erosion as that lava is pushed down. And then you can see this outflow channel here, which mostly is crusted over. But there's some incandescent glow here. So it is pooling up in this flatter topography around the vent, it would appear. From Geologist, there was a reported tremor and uplift not long before this happened. Is this related? Many thanks again. Yeah, I don't know. I know the earthquake data is a nothing burger, so there's just nothing here when we look at the last 24 hours around the area. And I've got it set for all earthquakes. It's nada, right? Like those earthquakes over here are too far away. Our eruptive vent is right about here, and so there's absolutely no seismic data, at least on this plot here. So not much we're seeing on that front. From David Maher, Shawn, just a question about the driving force for the lava. Is this eruption driven by the mass of liquid lava, or is it the gases in the lava that's the driving force, or a combo of both? It's mainly the gases. So this lava molten rock material is very dense. This stuff should not be coming to the surface, but it is because of the gas content. Now when it reaches the surface and you see these big explosions of lava here, a lot of that gas goes straight up into the atmosphere, and that's what this plume of gas that you can see drifting off to the right here is. So it's just the gases are providing the buoyancy and propelling the magma up towards the surface. Once it reaches the surface, like we see here in the spatter cone, those gases are released for the most part up into the atmosphere. There's still gases trapped in this lava even as it's flowing down here, but the lion's share of the gases are released into the atmosphere right here. And so you would not want to be downwind of this bluish gray plume here. This would be some nasty stuff to breathe. From Aim Here 2000, I think this person's just letting us know that the tube collapse that started all this is on the Hagafelt camera at 257. Um, and I don't know the MBL camera. That's the one I'm on. I don't know if I can go back to 257. Is that going to be too far back? Oh, I can get there probably. Let's see if we can do this. Let's see if we can see what this person saw. So we're at 249, 254, 256. And what, let me pause it real quick. 257.35. Okay, so according to this person, in the next 1 minute of this video, we should see the tube collapse that started all of this. There's the flow, there's the lower vent. So let's kind of fix our attention on this area here. Looks like, was there something picked up here? Let's see, we're at 257 now, so in the next 35 seconds. There's also some flow coming out here that it's going across the camera view here at the bottom. I'm not quite sure what's going on there, so I'm going to kind of watch both. All right, we're 20 seconds away, 15 seconds away from the tube collapse, or what they're calling a tube collapse. So I'm interested to see what this shows. 5 seconds. 3, 2, 1. I didn't pick out anything different there, but maybe I missed something. Yeah, and this could be part of a tube system here, because it is mostly black, but you can see there's a little bit of glow there, so it could be feeding. Hard to tell because it's during the daylight hours here. So aim here 2000. I might have missed whatever it is you saw there, so I apologize. Yeah, sorry about that if I missed whatever it is you were able to see. And then our last question on this sheet anyways from Martha, another one from Martha Jamsa. Is this connected to the recent uplift of the past 3 to 4 days? And they say awesome. Hard to say. I don't think right now, my best guess is this is just the there's some sort of impediment or something that choked off that channel through the base of the spatter cone that led to the lava lake rising. I don't think we have any data right now to suggest that the inflation that we've been seeing over the last few days is related to this. But that remains to be seen. So right now it's just good hypotheses and sort of spitballing, and then hopefully we'll be able to get some good hard data on this at some point. Okay, and Amanda Jo said she sent me a message. Oh, I was at the wrong point in time? All right, team, sorry. Let me get, she says, you're on the wrong time. Go forward 2 hours. And then exclamation points. So for this view here, give me the timestamp I need to go to on this view if I was doing it wrong. And I do apologize for that. Because I thought the person said to go to 1457.35, which would put it right about here. Is that not where I was? Maybe I wasn't there. Oh, okay. So now I'm seeing something different. So there's the flow here. Lava Lake's low. Sorry if I was at the wrong point there, team. It's much easier to yell at me in person than with text messages. Let me just verify with my other screen here that I'm in the right spot. Good now, I'm in the right spot. Someone let me know that this is the right place to be. 1457 is what they say, and it says 1456 and 40 seconds. Okay, so let me go back and look at that. So the flow channel coming out, and do we have like a breakout here along the base? Everyone else has probably figured this out but me, so I'll just have to. You're all yelling at your computers right now like, you idiot, it's right there. I just hadn't seen this in real time, so I want to see this actually develop. Okay, Manda Joe setting me straight. I was looking at the wrong time. I couldn't quite see the timestamp underneath some of the little buttons there. All right, so I'm at 14. Do I need to scoot forward just a skosh? I probably don't dare. I'll just leave it going right there. So it's at 1456. Here's our lava channel. I can see some of the movement through that coming out the base. And then presumably around 1457 is when this changes a little bit here. I could see a little bit of a flow over here. Yeah, and so now it's starting to, oh yeah, I think that's just a channel overflow. Interesting. But that's apparently not tied to, so that would just be a breakout, a channel breakout, another one over here. Is that what other folks are seeing as well? You can see it kind of racing down into this little pathway here. So it's ponding right here, and then it just starts cruising through this low area. But this all preceded and presumably was different or separate from the actual plugging of the channel that took place a little bit later. Does that sound right? Okay. Someone's saying wait for it. Is there more? So we've got this flow in the foreground out of this ponded lava area here. That's interesting there. Almost like, looked like a little bit of drain back. And then presumably is this about when everything gets plugged up? So then we get all this flow here coming out of the pond. That's going to drop the level down here. We got these little perched levees along the margin. Little section breaking off here. Yeah, it'd be interesting to see like where did this go? Did this just end up ponding up somewhere north of Hagafelt, or where did that this pathway actually go? Okay, well, I think I caught it all right. Look back and look down to the slow just beyond the opening. When the lava, let's see, when it starts to plug up, when that pond overflow stops. It plugged at this point, you can see the level of the pond dropping. Yeah, so the pond out here on the flow field's dropping. 15, 10, 26. So then 10 minutes later, something else happens. So there's all that draining. So they're saying 1510 on this cam is something. Okay, so let's see here. There's 1510. You can still see some of the flow out of this perched pond, or this pond, I suppose. It's moving across here. Oh yeah, look at that there. It just dropped down. That whole piece just like sunk down. So prior to the overspill and the lava lake rise, this pond, so maybe that's where the system got plugged up on the outside out here versus on the inside in the cone. That's a yeah, I guess I assumed it had been plugged up from the inside, but this actually makes a little bit more sense. So as the pond drops, some of these slabs of crust are plugging up this outlet, and that's what brings the lava lake up. Does that sound right? Hopefully. Oh yeah, someone just told me you can use your arrow key to skip forwards and backwards 5 seconds. Brilliant. That's why we need the whole team here, because especially with technology, I am not. Oh, that's way better than grabbing the little scroll thing. So now I'm just kind of skipping ahead. Oh boy, I skipped too far. See, I was impatient. So then we're at like 3:11 local time. I guess I'm just wondering, can you see how quickly does that lava level in the crater actually rise? Because this is dropped. There's still flow coming out of the pond, but it doesn't look like there's any flow here. So presumably the lava level in the crater is starting to rise. And can you see that? Now we're at about 3:13. And at what point do we start getting flow over the rim? It's pretty soon in here, wasn't it? So now we're at 3:15. Looks like it's starting to rise a little bit. I think so. Yeah, yeah, look, you can see the whole top of it there. So now by 3:17, that lava level's risen. And then thanks for the arrow key tip, team. Like, that's way better than dragging the little dot on the scroll bar and pulling it across. Now we're at 3:19. It's right there, boom, and then that's close to our first spillover at about almost 3:20. So, and then it just kind of goes from there. Very cool. Hopefully I caught all the good stuff. So, very nice. Okay. Sorry, I was in a bit of a rabbit hole with that one. Just kind of focused on catching all the good stuff. So, where are we at now with this thing? So there's our live view, and let me switch over to anything from Amanda Joe. Next, go here to see flow to the west from behind. Okay. See, I just need someone to tell me what to do. I'm good that way. Okay, so we're going to have a different view from the MBL crater or webcam. Okay, so this is looking to the west, and it looks like some of that lava that was spilling out to the west is maybe turned around here to the north, potentially. If we go back a bit, maybe we can see that, maybe not. So notice that until this thing starts to spill over, you don't see much lava clearing the rim. I mean, you see it bubbling up a little bit, but then presumably, as we get closer to the live view, oh, there's a section of it dropped. Do you guys see that? Watch this little top section of the spatter cone when I jump ahead. See how it's gone? Right there. So some pieces collapsing inward. Little chunk gone there. Yeah, and then you start getting a little sense of this flow. So there's that start of that flow lobe coming out the west side, and looks like it's wrapping around to the north of the cone. Because if I skip forward, you can see it right here on the right side. Very cool. Thanks for sending that, Amanda Joe. And there's our live view there. So, yeah, but what we really want is an aerial view. I just want to see it all from the top down just once. But we're not seeing that. That's okay. Okay, where are we at here? Good stuff. And I probably need to peel away here soon. I can probably do another 20 minutes, and then I need to drive down to Salt Lake City. So let's see our view here. Cool stuff. Our view there. It's getting darker now, kind of twilight. Man, just The eruption went from good to better, right? And still no Met Office update. Not judging, just making sure that's what we see. And then the backside view. So we're kind of just left with these webcams, team, um, until we can get some other data. What's right there? Is that someone on the ground, or is that just a little, can't quite tell. Um, okay, so I think, unless I mistook something, we managed to piece together most of the sequence of events. So thanks for helping me with that, team, because some of you had been seeing that either live or you scrolled back and saw some of those things. And did I get to all the questions on that sheet? I did. Okay, good. So, and can maybe do a few more questions if there are any. Yeah, we're very spoiled for wanting an aerial view, right? Like, hey, just show us, right? Um, yeah, let's go back to this view. This is pretty nice. In terms of duration and like, I mean, again, we're just spitballing ideas here, team. Nothing we're about to say or consider is concrete. I believe, this eruption more than any of the others is, I think all the phases of this whole sequence starting in November has at least kind of taught me, and I guess all of us to some degree, that, just when we think we've got it kind of figured out, little curveballs here and there. Um, but this could go on for some time through this vent. We know that the magma influx into the system is still taking place. There's some slight detection of inflation going on in the area. And so the magma supply doesn't seem to be waning. And with this very clear pathway established, the eruption from this vent could go on for days, certainly, weeks, very possibly, and maybe even months. Selfishly, what I'm really hoping for is that this keeps going on from this vent in a sustained, steady way, so that the access to the area is maybe relaxed a little bit. Maybe people can, climb the Hagafelt, the hill nearby from the Blue Lagoon area, and then watch it from that distance or something. So, but that's up to the Icelandic officials. But I'll be there in mid-May, and naturally, I would very much like to see an eruption. And this one looks juicy. This one looks good. Let's see here. So a couple more questions were just sent to me from Amanda Jo, from the viewers. So let's just wrap up with these questions here and then kind of see where we're at time-wise. So from Joanne Kellum, who makes great hats and beanies, she says, it looks to me like the cone is continuing to fill, even though a large amount is spilling out over the side. Would you expect the sides to further erode from the overflow? I mean, it's this balancing act between the lava sticking to the sides and building up, like right on here on this right side. This is definitely in an aggradation mode that's building up this side. But what we've also seen sometimes is, as the heat in the vent, in the cone, in the crater occurs, sometimes these oversteepened walls can collapse. Now, right now, there's lava rising to a high point in the crater, so that presumably will keep some of these walls from collapsing wholesale. But she says, would you expect the sides to further erode from the overflow? I think there could be some thermal erosion happening here. And so as that cuts deeper, that may lower the level of the lava lake, the lava level inside the crater. So I can't say for sure that there's thermal erosion happening. But this type of behavior often leads to thermal erosion along the bottom of this channel. It's hard for us to actually say how thick or how deep the, from the top of the lava flow is to the base of the spatter cone walls beneath this flowing lava. Is it, a couple meters? Is it more than that potentially? Hard to say. I would guess just the way it's behaving and cascading over, it's maybe 1 to 3 meters would be my just kind of guess. But it might deepen as more of this flowing hot lava erodes the channel bottom that it's traveling over. So good question, Joanne. From PMA, could this end up creating a new fissure closer to the town? I don't think so. I think this type of behavior may is sustainable. If the magma influx from deep is more or less being balanced by the outflow of magma from this vent, I don't see any reason why a new vent would need to be opened. Remember that this is an efficient way to transport this magma to the surface. The only reason that would necessitate a second vent would be that the magma rising it can't all get through this conduit, right? So if this thing gets plugged up somehow, or it can't maintain the influx of magma from deep and it becomes more pressurized, that's when the magma is going to have to find some new pathway to the surface. Right now, I would guess that the pathway it might take is one of those other cones or vents that were active just a few days or a week or so ago. As those continue to solidify, if there were to be a new vent, it becomes harder to estimate where that might be. But not expecting anything right now, and definitely not anything closer to the town based on what we're seeing here. From Benny P7, isn't this clearly an increase in the volume output of lava, not just a blockage of the previous vent at the base? I'm not sure. If I had to guess, I would say I think the lower lava outlet at the base of the cone being plugged up or compromised somehow makes the most sense to me. If the data comes out in a few hours or tomorrow that shows that the lava output from the vent was increased somehow, I'd be okay with that too. So I'm not really, I don't have a dog in the fight. I think visually though, it looks like there's more lava coming out because it's spilling over the top, whereas previously you were used to seeing it spatter a little bit from the top there, from the crater, but a good portion of the lava was coming out of that base conduit at the bottom of the cone and then feeding this lava channel. So visually it looks like a larger amount of volume, but we just don't have numbers right now to say if that's true. So from Janet Clancy, could the flow and ponding be broken by maybe exploding the levee and allowing it to flow in a safer direction? I doubt they would go to that kind of measure. And as far as we know right now, there's nothing wrong with the direction it's going. It's not going in an unsafe direction, as far as we know. Yeah, and just not a lot of, it would have to be really extreme to come to, to have a solution of, well, the only way to get this thing safer is to detonate one side of the spatter cone, open up a new outlet so it could go that way. Because you might create more problems than not, right? We know that this vent sits on a regional slope to the south. So all things being equal, based on the topography that was there before this eruption began, the lava mainly should be going to the south. You might get some to the west, you might get some to the east, very little to the north because the regional slope is from north to south. And unfortunately, that's where the town sits, guarded by those defensive berms. So, yeah, but could you try that? I mean, if this was like a little scaled experiment on a table, it'd be fun to, if you could shrink this down and make it like a video game or something, it'd be fun to try different solutions. But I highly doubt that the Icelandic government would decide to detonate or explode one side of the cone to get the lava flowing in a different direction. So, but it's a fun thought experiment nonetheless. From Greblav, how much would 1 liter of this lava weigh? Oh boy. Shoot, I did a calculation with that one time in the past. Can I quickly do that? So the density of basalt, 1 liter. I probably, uh, I probably can't do that on the fly really quickly. Um, so I'll let you do the math on your own if you want to. So I'm just looking up the density of basalt's around 3 grams per cubic centimeter. So you're going to first need to turn cubic centimeters into liters, and then you might take, but that's basalt. It has a little bit of a range there. Let's see if it's a, oh, here we go. So this is telling us, the internet never lies, right? That lava density is about 3,100 kilograms per cubic meter. Lava density in liters. Let's try that. I'm just Google searching some of these questions you had. See, because I can't think of it through right now. What is the weight of lava? Yeah, I don't know. I'd say just get on the internet and try a couple things there. I can't. I can do it, of course, but I'm just lazy right now, not wanting to crank the numbers out. Sorry. Peter Eckhoff, with a fairly flat land level rise and the high lava flow, does that indicate that the underground plumbing is opening up? Where might we see additional eruptions southwest and or northeast of this cone? Well, the underground plumbing system that's supplying the magma, that's just still a big black hole. We don't have any clear clues as to what's going on there other than the magma it was and still is accumulating to some degree over near Svartsengi. That's where we're seeing the uplift. And from there, it has a pathway mostly laterally and then up to the east to these vents. If you're talking about where might we see additional eruptions southwest or northeast of this cone? Right now with this steady flow, like I'm not anticipating any other eruptive vents forming. That can change, of course, moving forward. If this shuts down, then we're going to go back to baseline and possibly have another eruption, possibly through these vents, possibly through other ones there. Yeah, hopefully I answered that there. I don't feel like I did a great job, but maybe that helps you with some insights there. From Shawn New, could the thermal erosion be viewed similar to water over ice? Yeah, I think so. You get in glaciers, you see the same thing, right? You get moving water on the glacier, and that water will cut down and create these little narrow, deep canyons, moulins, I think is what they're called, on the surface of a glacier. And this is also behavior we see if you've ever been in a lava tube. Lava tubes can sometimes be keyhole shaped where they're wider at the top, but at the bottom they're narrower because that lava tube gets established. And if it's a long-lived lava tube, it will thermally erode downward. So we're only a few hours into this, so the fact that it doesn't look like there's appreciable thermal erosion going on right now isn't too surprising. But when I wake up tomorrow morning and check the webcam, it might be interesting to see if that's dropped a little bit. If the lava lake level has dropped a little bit. Now that necessitates that the lava supply is maintained. Then if there's thermal erosion happening here, we would see that cut down a little bit deeper. So from Vivid Magic, in your last update, a little spatter thingy was just in front of the cone at the start of the stream. Did this little spatter help forming this new overflow? Yeah, I remember that update. It was kind of down in this area here. And at the time, I don't even remember what I said about that. I thought maybe some of the lava being fed into the cone had found some new outlet there. But in reading some of the comments from other people, others thought that it was sort of this lava pond kind of flipping over or the crust falling in. So I'm not sure exactly what happened there, but I don't think that had any bearing on the sequence of events that have happened today. And isn't that just gorgeous right there? I mean, we have this black foreground spatter cone, this fantastic yellow and orange lava spilling out, and then this snow-frosted mountains in the background. Like, let's just take a minute and soak that in. It's pretty awesome. Okay. Two more questions here. Tom Day, could the volume of lava have increased to cause the overflow in the main cone? Yeah, similar to, I think someone else asked that question as well. Possibly. I don't know. If that is the case, I'm okay with that. So if we have lava volume increase, okay. But What would cause that? Maybe the lava that was causing the uplift in the storage system underneath Svartsengi. Did that lava, as some of the lava was coming up and some was going into storage, did that get sort of carried with it and emptied out? Until we have the GPS data and some flow measurements from this eruptive area, I can't say for sure, but possibly. But I also think we can have this sequence of events, like I said, taking place possibly with the plugging of the base conduit, raising the lava lake level up to where it is now, and then spill over. I feel like either one of those hypotheses could be very much the case here. And then the last question from Seshu. I know this is a random question, but where at the lava or at what conditions does obsidian form from lava magma? Well, this is the wrong type of system in terms of chemistry to generate obsidian. This is basaltic lava. This is lava that is low in silica. This is lava that is obviously, as you can see here, quite runny, high temperature, and flows very readily. Obsidian, if we wanted to see a eruption of lava from a volcano that was forming obsidian, we would not see this splashy, runny lava. We would see thick, sticky, almost like toothpaste-like consistency, just stuff kind of welling up. It's not flowing very fast. It's just over-steepened. Occasionally it collapses, but it's not forming flows of lava for the most part. Or if it is, it's moving very slowly and sluggishly. And in that type of flow, if it cools quickly enough and if you have the right chemistry, especially water content plays a role there as well, then you might get obsidian. Obsidian will form from high silica lavas, or if it forms rock, it will form a rock called rhyolite. This eruption we're seeing here in Iceland is the opposite end of the spectrum. So this is what we call a very primitive lava. This is the material presumably coming up from depth in the Earth's mantle straight up to the surface. Sometimes if you get this stuff coming up and staying in the crust for longer periods of time, it can partially crystallize, and then through a process called crystal fractionation, it can start to evolve into more silica-rich lavas or magmas like we would see that would form rhyolite or obsidian. Good places to see those would be, and obsidian usually you don't see, there is a little bit of obsidian and rhyolite in Iceland, but better places would be on more continental settings, in California, in Oregon, and here in Idaho we have obsidian, places like that. So hopefully that was helpful as a question. So let's see, I got one more email from a viewer forwarded to me from Amanda Joe. Good evening, Shawn. The volume of lava flowing away from the spatter cone at the bottom vent seemed far lower in volume than the amount of lava that's been overflowing since 3:30 today. If the flow rate was the same, then wouldn't we have seen the same volume of lava coming through the vent that we are suggesting became blocked and caused the overflow? And there's another follow-up question here, but let me address that. Maybe. Again, I'm not saying that's an incorrect line of thinking. I think the basal vent, though, you weren't seeing all of the flow. You were seeing the top surface. We don't know how deep that channel was. There could have been a significant portion of the lava coming out of that basal conduit that was going into a subsurface tube system. I don't know. This is visually, this looks like way more lava. So I totally get the perspective that what you're seeing now looks more vigorous and higher volume than what we saw 10 hours ago. I just don't know if that's the case, and I think there's at least an argument to be made, potentially, that the lava output out of the system is essentially the same as what we saw like 12 hours ago. What makes us believe it was blocked? Well, we kind of saw, we saw the lava pond overflow collapse, and then it just didn't look, as we went back in time, like that conduit at the base was carrying the lava out. As many of you know, a day or two or 3 or 5 ago, you could see clear flowing lava coming out of that basal conduit with that bridge of spatter cone above it, and that was the primary channel. There was a little bit of spatter at the rim, but the lava flow, the channel, was 100% supplied by the basal output, or the vent, I guess, if you want to call it that, that was at the base of the cone. Yeah, so good question. That was from Hippogriffich. Time will tell, right? I'm okay being wrong. I like being right, but I'm okay being wrong. And so, regardless, it almost doesn't matter. What we now have is a different type of system. We have a elevated lava lake in the spatter cone. We have spillover of that lava that is feeding the same channel that was being fed previously. Is there more lava being fed into the system now, or is there more lava just visible in the system? And so optically, it looks like there's a greater volume spilling out of the cone, whereas before it was coming out the base. You didn't have a good view of it coming out of the base because it was being crusted over, and a lot of it might have been in a tube system. So those are just my thoughts, right or wrong, just a little bit of perspective there. So good stuff. Okay, so I'm going to probably shut this down in the next couple of minutes. Hopefully that was helpful. Happy to come in and spend a little bit of time with you today in between a little bit of family time this morning, and then needing to head out here in the next, boy, I need to head out soon and get down to meet my daughter and her girlfriend, take them out to dinner. And then I have a presentation tomorrow at the Utah Geological Association. I believe I will get a copy of that I can post here, so you can watch that if you would like to. So yeah, we'll just have to see how this looks moving forward. There's obviously other outlets for you to get your geology information, but I appreciate folks for jumping on here and spending time with me this afternoon or evening or morning or whatever the case may be. And of course, we always want to thank Amanda Jo for helping out with all the information. She's on there now as a moderator along with Susan. So thanks to them for helping out with this very impromptu, kind of quick hitting live stream. But it was fun to come in here and learn with you all. Thanks for your support of the channel, your kind words, your encouragement, your donations are very much appreciated and help us kind of keep this moving forward. So anything else? I'm just looking at the live chat. Any last minute? Yeah, hit the like button, do all the good things on YouTube, feed the algorithm. We want to grow the community. We want more people to engage with geology education. This is fantastic, team. I mean, here we are sitting in the comfort of our homes, watching Mother Earth just put on a fantastic display in the North Atlantic. How great is it that we live at this time where this is possible? I mean, things like this have happened in Iceland for thousands, if not millions of years, and we're finally in a day and age where we can all see it and participate in it to some degree, which is just wonderful. So, yeah, thanks for everyone for donating and helping out. I think I'm going to go ahead and shut this down so I can get home, grab my stuff, and go see my daughter, who I love so much. So thanks all of you for joining me today. I will be back in town. It's a short trip to Salt Lake. I'll be back tomorrow afternoon. On my way home, I'm going to try to do a random road cut video or two. And so look for some more content coming out. I still have some more information and videos from my trip to Europe. I know Iceland is like the thing right now, and I will give that as much attention as I'm able. But please also look at some of the other videos I have out there as well during some downtime you have, because there's some other great geology videos and content here on my YouTube channel. But thanks again to Susan. Thanks to Amanda Jo. Oh, one more thing real quick. She says, check Messenger. Amanda Jo says, what am I supposed to see here? The last thing I have on from you, Amanda Jo, is the exclamation points. Or is there something else I'm missing? I was trying to sign off there and then I got distracted. I don't see anything else, so I think that's it. Okay. All right. Thanks, team. We did it. It's great. I'm really interested to see how this plays out moving forward. It'll be awesome to see what we get from the Met Office. I'm sure by tomorrow, Monday, we should get some good information from them. Maybe a new flow field map, maybe some aerial imagery that will be helpful. I will try tomorrow. I might be able to, if I'm back in time and there's enough stuff coming out from Iceland, if I can put together a quick update, I will. Otherwise, I will see you sometime this week. Just we'll have to see how things look moving forward. So, all right, take care. Thank you. Be well. Enjoy the eruption. Enjoy nature. And we'll see you soon. Thanks, everyone.